Hi guys, and welcome back. Now, one of the questions that you probably ask yourself at the stage is, where on earth am I going to use trigonometry in my life? Why should I go through all this trouble? Well, I've got some good news for you. At least it's not that useless. And as a matter of fact, math, guys, is literally a part of our lives, an integral part of our lives. We use it every day, even in making some decisions. Yes, that's how practical mathematics is. So I'm going to introduce you guys to the concept of angles of elevation and depression. Some of these questions come in word problems, and you will need to draw a diagram actually to figure out what is happening in that problem. So I'm quickly going to give you a bit of a theory before we look into this problem, which you are probably reading and not probably listening to what I'm saying. Now, whenever we talk of, if you think about this, elevation, to elevate means to take something up, in the mall, you've got what, elevators, yeah. So to elevate means to take something up. So an angle of an elevation is an angle that you actually get when you look up, okay? And angle of depression should be down, should be opposite rather, so an angle that you get when you look down, okay? So I'm going to explain this in the most simplest way as I can, right? Hoping that you get. In all the triangles that we have set up, we have actually been dealing with angles of elevation. I hope you noticed. Yep, good if you did. Let me call this alpha. Oh, sorry. I should have actually changed that to a pen. So let me call that angle alpha. If this point is A and that point is B, then alpha is the angle of elevation, okay? Elevation, okay? Because I'm looking up from point A to point B. That's it. Very much easy. I don't want to complicate it any further. I'm going to leave it at that because that's how it is. On the other hand, I've seen a lot of students confusing this. Okay, so what's the difference between angle of elevation and angle of depression? Well, I'm going to use the same diagram and draw a line here. Let me get that nice feature. So that will enable me to draw a straight line. Actually, I should have probably changed the color of that line. So let's go for this. So if I draw the straight line here at point B, okay, then the angle of depression, so this is elevation. I'll do that. Elevation. Now, if suppose there's some rooftop at this point B here, okay? If I was to look down, then this here, let me call it theta, okay? Then theta is an angle of depression because I'm looking down, okay? I'm really looking down is an angle of depression. Alpha, I'm looking up is an angle of elevation. So yeah, just note that angle of depression. And oftentimes, guys, what happens is that you will need to set up a diagram, and write down exactly what they tell you. And you gotta use that and figure out probably the other angle in a triangle. So obviously, in most cases, that will be a right angle because it's trigonometry, right? And we know it comes from similar triangles and it works very well in right angle triangles, okay? So that's one thing that you can expect for sure. At least in grade 10, nothing is going to be complicated as long as we're following CAPS guidelines, yes. So all should be good. So that's about it. That's exactly what is meant when they say angle of depression angle at which you are looking down surface, angle of elevation, angle at which you are looking up a surface. So let's quickly solve this problem here. In a soccer match, a free kick is given 22 meters from the goal post, which are 4 meters high. Oh, okay, that information is enough. I can set up some triangle there. So let's see. A free kick is given, okay, and the posts are 4 meters high. So, okay, so I can add something like this. Okay, so of course there's a freehand drawing, but you're trying to describe for yourself what is given. You are told it is what? 22 meters from the goalpost, and the goalposts are what? 4 meters high. Now, come on. Obviously, the ground is what? Is horizontal, and the posts are what? Vertical. So the angle from that should be a 90-degree angle. I hope we can all see that and think of that. Okay. Now, so obviously this is the point at which the free kick is given. What are they saying here? The player, there's a player, let's call this point P to say this is where the player is, okay? The player aims to kick the ball such that the angle of elevation, angle of elevation is maximum. Maximum, what does it mean? Is the largest, okay? So we are dealing with an angle of elevation here, so I do not need to confuse myself. Let me call this elevation beta, maybe for ball, because it's kicking a ball. Doesn't matter, you could have used beta, you could have used alpha. It's cool. So angle of elevation, such that the angle of elevation is maximum in order to score a goal for his team. So we are even something here. This guy aims to score a goal. He wants the ball to go in the net. And probably the reason he wants the maximum angle is so that the keeper will not have a chance to catch this, right? Yeah, I'm sure you've watched soccer, you've seen such crazy moments, right? So calculate the maximum angle for which the player is to take the shot. So obviously, you got to find this angle. Now, what am I given? I'm given this side here, and I'm given that side there. So let me think back. Which ratio in relation to this angle will relate to these two sides? Or which ratio, I mean, if the angle is there, then this side is opposite, and this side is adjacent. That's what I'm given. So I got to work with what I'm given. So which ratio actually, so I'm answering A here, relates the opposite and the adjacent? Well, you got to think soccer, opposite, adjacent, there we are. We got you tan. So I'm going to say tan beta is 4 meters opposite, 2 meters adjacent, and the m just takes the m away already. Then I know we've done this, guys. I've shown you in trig equations what you do when you solve this. So you gotta punch this in your calculator, and I'm gonna do just that on my calculator here, which you cannot see, but you can trust me. Beta is 10.3 rounded off to correct 1 decimal place, and that is the maximum angle that this guy has got to kick the ball if he wants the goal. Now B, you are asked what should be the distance that the ball will travel if kicked at this maximum angle. In other words, find the hypotenuse, because this is how the ball is going to travel. He's going to kick it at this angle, and the ball is going to go up. There it is, okay? Hoping it goes in somewhere there, yeah, those miraculous moments, but you can see, you can actually calculate it using trigonometry. Oh, probably that's what these big players do. Maybe they've got mathematicians helping them. You don't know, kidding. But I know one thing, teams have got analysts in them, and those guys have their math absolutely spot on. Yeah, so what is that distance, guys? At this point, you can quickly decide which method you want to use. You could go Pythagoras theorem and say 4 meters squared plus 22 meters squared should give me the hypotenuse squared. Even if you write that, that's okay with me. Or you could have said, wait, which trig ratio relate to this and that, because I now know the angle. You just calculated the angle. So for those of you who are very confident with what you're doing and you don't doubt your answer, in any case, you know opposite and hypotenuse, there it is sine. So you can go ahead and say sine 10.3 is actually opposite 4 meters over what? Hypotenuse. Maybe what you may want to do, instead of writing hypotenuse, you may label that side X or Y, whichever variable you like. And yeah, and that's what I should do here. I should put up an X. So I should say that. Yes. And then we all know what's going to happen here. If you're going to make X the subject of the formula, and X is 4 over sine 10.3. And that's all you got to do to find your answer, which will be in meters. See, and they ask you a question there, right? And they're asking, the player kicks the ball at an angle of 15 degrees. Will this be a goal? And you got to explain yourself. Well, let's see, the maximum angle is 10. 15 degrees is bigger than 10. Wait a minute. No. This guy is going to take the ball way up. It's seized by 4.7 degrees. The ball will be above the post. You understand? So it will obviously not be a goal. That's how easy these things are, guys. Well, hope you enjoy. See you later.